All right, folks. So today we are going to discuss more about string methods. Last class we discussed string objects, and we talked about how strings have methods built in. So we talked about the concat and replace and to uppercase methods a little bit. And today we're going to go more in depth about more specific string methods, some of the most useful ones, and a variety of other interesting and fun topics. So let's just jump into it. So an important piece of information when we're working with strings is knowing that each string object, every string that we make, contains a sequence of characters. That's how you make a string. And every character in a string has what's called an index. And the index of a character is going to be a number referring to where in the string that character can be found. It's its position in the string. In Java and many programming languages, counting is going to start at 0. So if I make my string howdy, H-O-W-D-Y, I have 5 characters. My first index is going to be 0, and then the indices or indexes, whichever you prefer for multiplying the word index, they're going to increase by 1 until we hit 1 less than the number of characters. So, like I just said, first index 0. Our last index is 1 less than the number of characters, because we have 5 characters. So our last number is going to be 4, because we've shifted down by 1 to start at 0. And that's how most programming languages work. That's just something to remember. Counting is going to start at 0. If I want to access a specific character within the string, within a string, I can use the char at and then give it some index to access some specific character. So if I make my string variable and I make it equal howdy, like I did before, and I system.out.println my string.char at, this will return whatever character is at index 2 within my string. So if we look 0, 1, 2, we're going to get W. We're going to print W. So does that idea make sense? How we can index strings and find a specific character. Cool, right? So today we're going to cover these different string methods. First, let's look at .length. The .length method will return the number of characters found in a string. And this is going to include any and every character, which is all the letters, all the non-alphabetical characters, which is like spaces and punctuation and numbers. So anything within our quotes is going to count. So if we look at our string here, we have howdy there, and my int string length, strlen, is going to equal my string.length. So it's going to return whatever value. We're going to save it into a variable, and then we're going to print it. So if we count, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 characters. So we're going to print 12. That is how many characters exist within my string here. Does that make sense? Length is a pretty simple one. All right. Next, let's talk about substring. This one's going to be a little bit more complex. So a string.substring, we're going to give it 2 numbers. We're going to give it a from, and we're going to give it a to. So it's going to return a new string object starting at the index from, so starting at the first number, and ending at the index 2 minus 1. And the reason this is going to return a new string is because, like we talked about last class, strings are immutable, so I can't change the string. I can't update whatever's inside of it without completely overwriting it. So this is going to make a new string object and return it based on whatever parameters I'm passing. So if we look at our code, we have the same string, howdy there. We're going to make a new string, substr, equaling mystring.substring. We're going to start at 0, and we're going to stop at 3. So what is the last index that's going to be included?
Four.
So it is very close. We're going to go the other direction. So we're going to go to 2 minus 1. So we're going to stop at 2, at the number 2. So if I list out my indices underneath all my characters here, I'm going to start at 0, and I'm going to end right before my end index. So my bars that I'm placing essentially are right before the 2 indices that are in my positions here. So what we're going to get is this string how. So when I print my substring, I will print how. Does that make sense how we grab a chunk out of a string? Sure, all right. If I want to simulate the char@, method with my substring method, we can use the index that we want as the start, as the from, and we can just use the next integer value as the end, as the to value. So if I want to grab from index 6, if I want to pretend I'm doing char@6, I can substring starting at 6 and ending at 7. So we're going to start at 6, and we're going to end right before 7. So we're just going to get whatever is in index number 6. Now, this isn't especially useful because we have the char@ method, but it is possible to get just one letter out of a string, or one character, because they're not always going to be letters. If I use only one parameter for my .substring, this will return a string object starting at the index we state and just continuing to the end of the original string. So if my string is still howdy there, if I say my substring is mystring.substring 7, with our indices, we're going to start at 7, and we're just going to continue onward to the end of our string. And this is an example of overloading, because we are using only one parameter instead of 2 parameters for the same method. So the string class has the substring method overloaded to accept these these 2 different numbers of parameters. So my substring is going to start at 7, go to the end, and that's going to give us here with an exclamation point. Does that all make sense, how we can use the substring in 2 different ways? Sweet. All right, so what do we think is going to happen in this code if I try to make my substring starting at index 6, going to index 15? Is there an index 15 in my string here? There's not. So what do we think was going to happen here? What are some possibilities?
Loop back to the start.
It could loop back to the start, sure. What else could happen?
Error message.
We could get an error, yeah. Any other possibilities?
It just puts in the last number or value, I guess.
Go until the end. Yeah? Sure. All right. Those all seem like good guesses. And the correct answer is, drum roll, we will get an error. So if we try to access an index that is not within our proper range of indices, we're going to get an index out of bounds exception. We're going to get a big old fancy error saying, hey, you can't do that. That index that you tried to use appears to be out of bounds for this string. Like that's not within our boundaries. You cannot use that. So just be aware while you're working with strings, while you're doing substrings and things like that with the indices, always be sure that you're not trying to access an index that is beyond your list of indices. All right. Next, we're going to look at index of, which is just a bit simpler. The index of, and we're going to pass it a string as a parameter. And this method will return the first index at which this string that you pass can be found within the original string. So if my string is still howdy there, and I make an index variable in my int ind, is going to equal my string dot index of e. So what is the index of e? We bring up our list of indices again. What number are we going to see printed out?
8.
We are going to see 8. Absolutely correct. So we're going to see the first place that the letter E appears in this string, which is at index number 8. Now, I can also make my my string that I'm looking for be more than one character. If it's more than one character long, it's going to look for that exact match within my string. So at what index can I find this substring? Where in my string does this start?
10 and 11.
So it's going to encompass indices 10 and 11. But since we can only save one number here, we're just going to care about the index where that substring is going to start the match. So our number is going to be 10. So it's going to match right there. We're going to grab that first index and we're going to print out 10. What do we think we're going to get if I try to find the index of some substring, some character that's not in my original string? What do you think is going to happen? What are some possibilities?
Error.
We could get an error. What else could happen? Or is that the only option? All right, well.
It'll say like -1.
It'll say -1. All right, that is a good guess because that is correct. When the index of method cannot find the string that you're trying to find, the little party popper, very well done. When it cannot find it, it's going to say -1. It's not going to crash our program. It is going to say, hey, I didn't find that. So the index where you can find it is -1. And since we do not have a -1 index here, it's not going to be able to find it. It's not going to work. Does that make sense? That track? Cool. All right. All right, let's talk about dot equals. The dot equals method, which is going to accept another string as a parameter, it will return the Boolean value true or false, depending on whether the two strings are equivalent. So if my string is howdy there and string 2 is hey there, match is going to equal my string dot equals string 2. So does my string equal string 2? Those are not the same. So we're going to get false because howdy there does not match hey there. Those are not the same string. What about howdy there and howdy there? If I say my string dot equals string 2, will those match now? Yes, they will. So now we will get true. So dot equals is pretty simple. Lets us know when two strings are the same as each other. All right, last one for today, we're going to talk about compare to. The compare to method, which also accepts another string, will return an integer value determining how far apart the two string values are lexicographically, which is a huge long word, and we'll get into what it means and why we use it and how we figure that out. So what it's going to do is it's going to compare the first character that is not equal between the two strings. So for between howdy there and hey there, we have E and O are the different ones. So when I say my string dot compare to string 2, my distance is going to be 10. Now, how did I come to this number? How do I calculate that number myself and figure out what it means? We're going to use a tool that is going to help us determine how far apart character values are. And that tool is called the ASCII Table. Boom, ASCII Table. ASCII stands for American Standard Code for Information Interchange. So this is the standard among all computers. So pretty much every computer is going to know this set of encodings. So the number 64 is going to represent the character at. The number 85 is going to equal the letter U, etc. Now, it is possible for us to have our own individual encodings on our own computer that might be more fun and interesting. But if we try to read whatever we've encoded on some other computer that doesn't know that encoding, it's going to come through as absolute gibberish. So because of the ASCII table and its further extension called Unicode, basically any symbol that we might want to represent on a computer has been given some number to represent it in our computer's memory, so that we can know that on any computer, if I see the number 67 that's representing something in a string, it's going to represent the letter C. So when we do that dot compare, it's going to find the ASCII value. It's going to find the number associated with that character. And it's going to subtract the value you're passing from the string you called it on. So if we're comparing howdy there to hey there, remember O and E are our first two different values. So let's find O. O has the character value 111. E's ASCII value is 101. So we're going to subtract from 111. We're going to subtract 101, which is going to give us 10. And since this number is greater than 0, so because it's not 0, it's bigger than 0, we know that howdy there is lexicographically greater than hey there. So, and we can kind of just think of this as where it's going to fit within the dictionary. If you were to look through the dictionary, would you find howdy before or after hey? Where in the dictionary would those two go? Would howdy come before hey, or how would howdy come after hey in the dictionary?
After.
Howdy is going to come after hey in the dictionary. That's what our lexicographical thing is going to mean. Essentially, finding things in the dictionary. Now, keep in mind that all of our capital letters have a smaller ASCII value than any lowercase letter. So if you compare an uppercase letter to a lowercase letter, it's always going to be smaller. It's going to be earlier in the dictionary. Does that whole idea make sense? How we can compare strings to each other? And these slides are on learnvcs.net, so if you need to reference them, by all means. And you can also find this ASCII table on the internet. You don't need to memorize these values. Just know that this is the underlying process by which we do comparisons for strings. All right, so if you remember back to when we added our scanner class to our programs, we needed to import scanner from the java.util package. The string class that we are using is part of the java.lang package. Classes within this package, the java.lang package, they're all made available to our programs by default. So we do not need to import anything from the java.lang package. They're already bundled into our programs by default. So let's go a little bit deeper and discuss what packages and classes and libraries even are and how they all interact. So a package is a group of related classes along with their methods, their instance variables, and constructors. Packages are part of programming libraries. So if we think of a library, libraries are just like a real library. They're collections of written works made by other authors or made by some author. So libraries in Java are collections of packages written by other people so that we can use them in our programs. So each library is a collection of packages, which are groups of associated classes. So the java.util package, java.lang package are all part of the Java library. And then within a package, all of the classes are going to be kind of similar in function to one another. So these are all going to be utility things within the Java class, and these are all going to be things related to the Java language. So each package's classes are like the chapters within a book. So I have the date class within java.util. I have the scanner class within java.util. I have system and string within my lang class. So we can use the system.out.println, system.in when we're doing input, we can use these classes because our java.lang is already in our program. That library already exists, or that package already exists from the Java library. Each class that is in a package has what's called an application programming interface, which shortens to API, which is a set of instructions on how to use it. So within the scanner class, we have next line, we have next int. Within our system, we have our print line, we have our print methods. These are all ways that we can interact with these classes that are part of these packages. And APIs allow us to use methods and classes without knowing how they work through documentation. So I can use documentation to figure out how to actually use the string class. If we remember, we can open up our string docs in Java, and we can find all of this information about how the string class works. We can see that it's part of the java.lang package. And if we scroll down, we can see here's all the constructors that we can use with this class. Here's all of the methods that we can use with this class, and here's how to use them. So this lets us interact with this class and know how to use it, even if we don't know how it was built. All right, last topic for today. I know this one's super long. So many classes that we use or write are going to include a toString method. The toString method is used to return a string representing the attributes of the class that you're calling it on. So when you have a class with a toString method, anytime an object of that type is printed, the toString method will automatically be called. Java will look within that object, see that it has a toString, and automatically call it. So if we look back at our rectangle example, let's look at how we might create a toString method. We're going to make it public. We're going to return a string. So our return type is going to be string. Our name is toString. And we don't need to pass any parameters to this method. It doesn't need to know anything to do its job. So I'm going to make a string called return string. It's going to equal a rectangle width, and then I'm going to have a new line escape character. I'm going to add width, and then I'm going to add the actual width value. I'm going to add a new line, and then the word height and the height value. And then I'm going to return the return string, and there should be a semicolon on that line. So this will return a string representing my rectangle class. So if I try to print the rectangle class without a toString, I'm going to see the name of my class, and then I'm going to see some sequence of letters and numbers. This is going to print the hash code for my object. It's not going to print any of the values associated with it. And I'm not entirely certain what the hash code represents. I've tried to figure it out. I have no idea. So after I implement my toString method within my rectangle, when I print line my rect, when I print that object, it's automatically going to call the toString. So when I print it, it's going to print a rectangle with width 6 and height 10. So we're just going to get that exactly printed out nicely. And when we have a toString, it will also automatically be called when that object is concatenated with a string. So if I make that same rectangle and I make an intro, say equaling I have, and I print intro plus my rect, it's going to concatenate whatever string comes out of the toString from my rect. It's going to add it to my I have, so it will make I have, and then the rest of it is going to be what came out of the toString, a rectangle width 6, height 10. Does how we use the toString method make sense? All right, I know that one was super duper long. That is the end of our presentation for today.